So let's use a piece of patty paper. We're going to draw a triangle, and then we're going to find the altitudes of that triangle. So I'm just going to start with an acute triangle. And the altitude is a line that is perpendicular to the side that goes through the opposite vertex. So I'm going to focus on this side and this vertex. So I need to make a perpendicular line through that. Now, it could hit anywhere on this line. It just needs to be perpendicular to it. So it doesn't mean it's going to be at the midpoint. That'd be a perpendicular bisector. So the way I'm going to use patty paper here is I want to line it up so this side here is matched up, but I want to make it so it's matched up, and this vertex, this opposite vertex that I want, is going to be on the fold. So I kind of have to move it around a little bit until I notice that down here it's going to be on the fold, and then I make a crease. So now it's on the line, opens up, and I have this mark now that is the altitude. So I can come in and draw back my pen. And that is the altitude of that side. Now I keep going. Let's look at this side. Spin it around. This side. I'm going to fold it so the sides match up. And the vertex over by my left hand here is on the fold. Open it up. It should go through the vertex as long as it's on the fold. And this one turns out to be perpendicular to the side. Now we go to our third side here. I'm going to fold it, line them up. I want it to be on the fold, about right there. Make my crease, open it up, and when I draw my third line, I'm going to notice it goes through where the other two lines went, and that is the point of concurrency for the altitudes, which we call the ortho center. Now, that's for an acute triangle. Let's do something different. Let's look at an obtuse triangle. So, here I have my obtuse triangle. I'm going to start with this side. So if I fold it and match them up, so again it's on the vertex, it looks like this. And you know what? I'm going to need to start over. That one's not quite going to work for us, and we'll see why in a minute. Let's make another obtuse triangle. It's not that it doesn't work, it's just I wouldn't have room on my paper. So I'll go more to the edge this time. This should work fine. Alright, so I'm going to take this side, I'm going to fold it over, I'm going to match them up. So my vertex is on the fold and the two sides are the same. There we go. And there is my first altitude for my right triangle. And just for this one, I'm going to draw it the full length that I have. Might have an idea where this one's going. So now I got to draw or find the other altitude for this side. Now if I look at this side and this vertex, it's clearly not going to be perpendicular to it. So what I'm going to do is actually extend this side that I started with out in that direction. Because if I drop down a perpendicular, it's going to hit right here. So, when I go to fold it, I'm still going to match up these sides, but now that vertex has to be on the fold, which is going to be right here. And now when I open it up, I get that perpendicular that I was looking for that drops straight down. So it's perpendicular here, but it hits the other point down here. Now for the third one. extend the side. I'm going to fold it so the vertex is lined up on the fold, the sides match, and I open it up and I see, oh, this one's a little bit off. That it's going to intersect, be perpendicular, and go to this point. So a little bit off there with our folding, but that would be our orthocenter for an obtuse triangle. So we have orthocenter in the acute, orthocenter in the obtuse, and it moves, and this is again where the altitudes meet.